Hello, my name is Dr. Dan Wedding, and this is DrWedding, VB14, 1D arrays, and the Fibonacci sequence. The Fibonacci sequence was covered in VB09, but it did not use arrays. In this video, we will rewrite the Fibonacci sequence using an array to save the sequence. The next three slides are the same as the slides that were in VB09. This information is covered to help you understand the program you're about to write. If you don't need this review, please jump over the next three slides. This is not a math class. It is a series of videos to help you learn to program. So this explanation of the Fibonacci sequence and the generalized Fibonacci sequence is going to be as short as possible. This explanation is not going into great depth and is here to help you understand the code that is going to be generated. When talking about the Fibonacci sequence, the word "the" is part of the name, just like The Ohio State University. The Fibonacci sequence is also called the Fibonacci series, the Fibonacci numbers, and other variations. The Fibonacci sequence starts with two numbers, 0 and 1. All of the remaining values are calculated by adding the two previous numbers. The Fibonacci sequence is shown below. Mathematicians use capital F to represent the Fibonacci sequence. A generalized Fibonacci sequence is a list of numbers that follow the Fibonacci rules but do not start at 0 and 1. A generalized Fibonacci sequence starts with two numbers, such as 2 and 4. All of the remaining values are calculated by adding the two previous numbers. A generalized Fibonacci sequence starting at 2 and 4 is shown below. Mathematicians use capital G to represent a generalized Fibonacci sequence. There are many online calculators for Fibonacci sequences. Two are listed below. You may wish to review them if you're interested. When filling in an array with a sequence, you always follow the same 5 steps. It does not matter if you're going to generate an estimate for your retirement, a Fibonacci sequence, or calculating the population growth of lemmings. The 5 steps that you always use are: collect the raw materials, generate the first equation, put the equation in a loop, make the loop index match the array index, verify that the array bounds are not exceeded. You can't bake a cake without the ingredients, and you can't generate a numeric sequence without the starting numbers. If you are going to generate an estimate for your retirement account, you would need to know how much you plan to save each year and the estimated growth. To calculate the population growth of a community of lemmings, you would need the current population and the growth rate. For the generalized Fibonacci sequence, you need two starting values. They will be stored in element 0 and element 1 of the array. Next, you write an equation using the raw materials. The first Fibonacci value that you can calculate is element 2, using the raw materials element 1 and element 0. An array is powerful when it is inside of a loop and the loop index matches the array index. So we need to put this in a loop. It's that simple. Just put it in a loop. An array is powerful when it is inside of a loop and the loop index matches the array index. So we need to make the array index match the loop index. This is simple. Just put a plus I next to the numbers inside the parentheses. You can cause your program to crash if you try to access element 10 in an array when the largest element is 9. This is called exceeding the array bounds, and it is bad. To prevent this, I like to use the train on a plateau rule. Assume there's a train with 0 cars and the train is on the top of a plateau. In the picture below, the train can safely move to 5 places on the top of the plateau. Assume a car is added to the train. In the picture below, you can see that the train can now safely move to 4 places on the top of the plateau. Assume a second car is added to the train. In the picture below, you can see that the train can now safely move to 3 places on the top of the plateau. Assume a third car is added to the train. In the picture below, you can see that the train can now safely move to 2 places on the top of the plateau. Assume a fourth car is added to the train. In the picture below, you can see that the train only has 1 safe place on the plateau. As you can see, as the train grows by 1, the track shrinks by 1. The train on the plateau rule states every time you add 1 to the array index, you must subtract 1 from the end of the loop. Think of it like this. Element 0 is the engine, and it is pulling 2 cars. The for loop is the track. Because the train grew by 2, the track needs to shrink by 2. The best way to learn how to generate a sequence in an array is by doing an example. I have opened up a new project named VB14 and generated a form. I have also filled in some comments. Inside the Fibonacci button, I have the 5 steps to generate the Fibonacci sequence. These 5 steps will work when you're generating any sequence of numbers. It could be an estimate of how much your retirement will be worth each year up to your retirement. It could be an amortization table for your house loan. Or it could be how much you're paying in interest on a credit card each month. It doesn't matter what the sequence is. These 5 steps should generate the answer. So let's start the Fibonacci sequence. I first need to get an array to put the values in. This is an integer array with 20 elements. The indexes are 0 through 19. Next, I need to collect the raw materials. For a Fibonacci sequence, the raw materials are just the first 2 values. So I'm going to use the same read statements that I've been using in the previous programs. I'm going to have an input box inside of a try-catch. The try-catch will be inside of a do loop, so I can limit what values are being entered. Because I'm starting the sequence, the array is not inside of a loop. I'm just reading the values into the 0th element and element 1. You'll also notice that in the do while loop of the second read, I'm comparing int fib1 to int fib0. That's because in a Fibonacci sequence, the second value has to be equal to or greater than the first value. Therefore, if the person types in a second value that's smaller than the first value, the loop will repeat and ask them for another value. Step 2 is just to generate the equation. If I have element 0 and I have element 1, I can generate element 2. This is not the final answer. This is a step along the way to the final answer. Normally I wouldn't have these steps written in my program. However, because you're learning the steps, I'm including them as comments. The next step is to put this equation inside of a loop. Because I'm going to be using a for loop, I'm going to need to declare the index I. Now I have to make the loop index match the array index. That's very simple. All I need to do is add I to the 3 indexes on the 3 array elements. The final step is to verify that I'm not exceeding the array boundaries. If you look at the equation in step 4, you'll see that the maximum value that I'm adding to I is 2. I'm adding a 0 to I, I'm adding a 1 to I, and I'm adding a 2 to the I. 2 is the maximum value I'm adding to the I. Therefore, I have to subtract 2 from the ending point of the for loop. This makes the maximum value for I 17. Therefore, when I is 17, the equation will be element 17 plus element 18 equals element 19. I plus 0 is 17, I plus 1 is 18, and I plus 2 is 19. This is the equation that we're looking for, so I can uncomment it and actually use it in my program. These 3 lines will generate the complete Fibonacci sequence for us. Now all I need to do is print it out. Let's run the program and see what happens. So I need to enter a number between 0 and 10. For example, 4. The second value needs to be 4 or greater, because in a Fibonacci sequence, the second value needs to be equal to or greater than the first value. If I were to type in a 2, it's going to rerun the loop and force me to enter a different value. Now we can see that I entered the 4 and the 6. 4 plus 6 is 10, 6 plus 10 is 16, 10 plus 16 is 26, and so on. Obviously, the intermediate steps we used to get the final answer should probably not be in the comments. However, they are here so that you can follow along and learn the procedure. If I ignore reading in the variables and printing out the array, then these 3 lines are really the complete program. You can see why an array becomes very powerful when used correctly. I'm now going to do a quick Roth IRA example. In this example, I'll read in how much will be deposited into the IRA each year and an estimated rate of return. I will then show the balance of the IRA for 40 years. First, I have to generate the variables. I've generated 3 variables, an array of 41 elements. Element 0 will be the starting value, and elements 1 through 40 will be the balance at the end of year 1 through 40. ROR stands for the estimated rate of return, and I will be the loop index. First, I have to collect my raw materials. My raw materials are going to be how much am I going to deposit each year into my Roth, which will be stored in Roth 0, and my estimated rate of return, which will be stored in ROR and will be a value between 1 and 10. I'll be reading these values in the same way that I read them in before. Once I read the 2 values in, I can write the equation. Here's the equation for the Roth IRA. The value at year 1 is equal to the value at year 0 after it has grown for a year. The growth is 1 plus ROR divided by 100. The double Roth 0 at the end that's being added to the value is the year 1 contribution. Next, we put it inside of a loop. Once it's inside of a loop, we make the loop index match the array index. you'll notice I did not add an I to this array index. That's because I actually want that exact value to be added each year. That's the initial contribution and the yearly contribution. Therefore, I don't want this one to move with the loop. Next, I have to change the stopping condition of the for loop. The maximum value that I've added to I in this equation is 1. Therefore, the maximum value of the loop has to have 1 subtracted from it. And now you have the complete program for calculating the Roth IRA. All I need to do now is print out the information to the screen. Now that I've printed out the array, let's run the program and see what happens. We'll select the Roth button and enter 6,500, the maximum Roth contribution for 2024. We'll assume an 8% growth, and we can see that at year 0 we had 6,500. The 6,500 grew by 8%, and we deposited another 6,500, bringing our total up to 13,520. That 13,520 grew by 8%, and we deposited another $6,500. At the end of 40 years, the Roth IRA is worth $1.8 million. This method of generating a list works independent of the language. This will work in C or C# or Java or Python. I hope this program has helped you understand how to generate a list and fill in an array. In review, when filling an array with a sequence, you always follow the same 5 steps. These steps are: collect the raw materials, get all the values you need to calculate the next value in the list, generate the first equation, use the raw materials collected in step 1 to generate the equation. The equation will not be in a loop, and the array indexes will be numbers. Put the equation inside of a loop. It's that simple. Put the equation in a loop. Make the loop index match the array index. Add the loop index to the numbers in the array index. Verify the array bounds are not exceeded. Look at the array indexes inside the loop. Find the largest value that was added to the loop index. Whatever that value is, subtract it from the stopping value of the for loop. If you find these videos useful, please like and subscribe. It is the only way I can continue to make these videos.